If you've used the internet, which is pretty obvious because you're watching this lesson on the internet, there's a good chance that you have directly interacted with a version control system. These are systems that ensure that many people can work on one thing and not get tangled up in all the changes and versions. This also makes sure that we don't lose stuff. Let's look at why exactly this is such a big deal in software development. Programming today is a very different picture from what it was 50 years ago. Back in the day, 1,000 lines of code was an impressive feat. Yes, you heard me right. 1,000 lines. You're probably laughing to yourself and thinking that you can sit on a computer right now and type 1,000 lines of code without cracking your head. You can, and it is entirely possible. In the early days, computers were notoriously difficult to program and couldn't really do much, even if you could program them. This meant that programs couldn't get any bigger than a few hundred lines. In contrast, modern operating systems can contain upwards of 1 million lines of code. Wow, there just has to be a way of keeping track of all of this. When developing software, especially using agile methodology, there are a lot of versions of the source code. The code itself can be a lot of code. Remember the millions of lines of code that we just talked about? Ultimately, only one version of the software is released for use in the target environment, while developers are working on the project. They use what is called a version control system. This ensures that whenever they're writing code and they decide to change something or remove it entirely, there is always a way of going back without doing a ton of work. The need for a logical way to arrange and monitor revisions has existed for almost as long as writing code has existed. But version control became even more essential and complex when the age of computers began. The numbering of book editions and of specification revisions are examples that date back to the print-only era. Fast forward to the modern day, the most elaborate version control systems are the ones used in software development, where a team of people may concurrently make changes to the same files. The first popular version control system was a proprietary Unix tool called SCCS, Source Code Control System, from way back in the 1970s. It was followed by the Revision Control System, and later Concurrent Version System. Fast forward to today, the most popular version control systems are Subversion and Git, Git. Git especially is so popular that you hardly ever talk about software development without mentioning it. Oh, and by the way, anytime you hear the words version control, source code management systems, or revision control systems, know that they all refer to the same thing. They're all methods, or more appropriately, systems that keep multiple versions of your files so that when you modify a file, you can still access the previous revisions. We've all come across tools that help in recording changes made to files. You may have already seen this in cloud services such as Google Drive, which allow you to download previous versions of files. Pretty much any and every cloud service that stores documents incorporates a version control system in one form or another. It may sound like it isn't such a big deal, but think about the last time you accidentally wrote over your photos after editing them. When using a version control system, you would have the original photo along with the new edited file, and that would pretty much save your bacon if you're working on a super important project where you can't afford to lose anything. Version control systems, VCSs, are usually standalone applications. But revision control is sometimes built into other software as part of the package, such as word processors and spreadsheets. Microsoft Office provides such a feature. Even Windows, Mac, and other operating systems provide such functionality. Some large websites that allow community collaboration have version control. A shining example here being Wikipedia. Content management systems like WordPress also come with version control as standard. Provision control enables users to revert a document to a previous revision. And this is really great news for editors, as they can track each other's edits, correct mistakes, and undo unwanted changes such as spamming and vandalism, which are now quite common, as you may have already encountered on the internet. In software engineering, version control is a class of systems responsible for managing changes to computer programs, documents, and pretty much any fairly large collection of data or information. So basically, version control is a component of software configuration management. Changes typically carry some sort of identification that is used to tell them apart. This identification is usually in the form of a letter, number, or a mix of both. If, for instance, a file is edited twice, then the second version of the file can be called Rev2. Each revision has a timestamp, which is literally what it sounds like. That is, the date and time at which the change was carried out, together with the name of the person that made the change. This provides functionality such as comparison, revision, reverts, and merges. Imagine 3 of you are working on a document. Then one accidentally deletes the document at 11 p.m. because they were working late and got tired and careless. Yikes. If you have a version control system, you can easily revert to the last copy of the document that was saved. The exact same thing applies to software development. Without using version control, you're literally skating on a knife. Any rookie mistake and all your clever algorithms are gone. A version control system provides backup, especially if the code has a lot of reverts. It also allows software teams to work efficiently as the team scales up to include more developers. Each member of the team has all the copies of the files they need and can look at the file history if they need something that was removed in a later revision. Here are a few things that an efficient control system allows us to do. Complete change history of files. This means that every file has all of its iterations preserved. Work concurrently. Several developers can work on the same project at the same time. Branch and merge. This refers to the creation of a separate branch in order to develop a new feature or work on a discovered bug. This is done so that whatever task is done, especially if it is experimental, does not cause disruptions and unwanted alterations in the master branch. If everything goes according to plan, then the new changes will be merged to the master branch. And if it doesn't, it will simply be discarded. This is a particularly important step for large projects. Track development. A version control system allows the development team to track the development of the software package, since there are many versions of the software package that are readily available. The software development team can keep track of every little thing that is created or changed in the software package. As of January 2020, GitHub reports having over 40 million users and more than 190 million repositories, including at least 28 million public repositories, making it the largest host of source code in the world. Now, there are 3 main types of version control systems: the localized version control system, the centralized version control system, and the distributed version control system. Let's look at each one in a bit more detail. Localized is the simplest of all version control systems and the most common. This simplicity is not without its drawbacks. We all like nice, simple things, although the simplicity carries quite a lot of risk. Data can be lost quite easily, as you may accidentally overwrite files. We've all probably been at a point where we lost all photos from a particularly cherished moment, all because of an absent-minded click. The high likelihood of losses drove the development of the centralized version control system approach. The centralized version control system attempts to do away with the risks of having precious code stored on one machine with a human element in the loop. This allows developers to access the files they need from a single machine. Unlike the localized system, files are readily available to all developers as all on a central location. Everyone on the system has access to what their peers are doing on the project. A certain degree of control is available to administrators on the project. It does, however, not deal with the fact that there is a single point of failure, which is the same thing we had to deal with localized systems. So the centralized version control system use a central server to store all the database and any other data that is used in the team's collaboration. But this is fertile ground for a single point failure, which won't be such a nice thing after you've written 10,000 lines of complex code. Now, this is one of the strongest driving points of our next stop, the distributed version control system. In a distributed version control system, each of the developers, or more broadly, users, have a local copy of the entire repository. So clients essentially check out a snapshot of the latest file on the repository. The local repository contains all the files and metadata that is found in the main repository. DVCs allows for automatic management of branching and merging. This means that except for pushing and pulling, the developer does not need to worry about those and other rudimentary housekeeping operations. This also means that the developer can work offline since they have a copy of the entire repository on their machine, which also serves as a backup, which is also a nice little thing as the backup is no longer located on a single machine. Technically, every machine connected to and communicating with the main server is a backup location. Although the data is technically stored centrally, these systems don't necessarily depend on the central server to store all the versions of a project file. Every checkout is a full backup of all the data. As with any system, there is a set of standard terminology that comes with version control systems. We will now look at a handful of the most common terms and dive into a bit of detail as to what they entail. Traditional revision control systems use a centralized model where all the revision control functions take place on a shared server. Without a defined access control system, if two developers try to edit the same file, the developers may end up overwriting each other's work. Centralized revision control systems attempt to tackle this problem head-on by using two different source management models, namely file locking and revision merging. File locking is the simplest method, which works by denying subsequent access requests and allows access to one request at a time. This essentially means that only one developer can access the copies on the central server at a time. It is only when the developer checks out a file that others can read that file, but no one can make changes to that file until the developer with the lock checks in the updated version or cancels the checkout. File locking has key advantages and disadvantages. It can provide some protection against difficult merge conflicts when a developer is busy with significant changes to a fairly large file or a number of sections in a file, or even a number of files. You may already have had the question at the back of your head that what if it takes too long to make the changes? It essentially means the files will have exclusive lock for the entire duration, and other developers may be tempted to bypass the revision control software and change the files on their machines, since they have a copy anyway. This is a perfect recipe for tangled spaghetti when the other changes are finally checked in. Sometimes it might not be so easy to see who has a file checked out. In a large organization, files can be left checked out and locked and lost in the sands of time as other work is taken on, especially if the file in question is not used often. This is the problem that the next type we're going to look at attempts to solve. Most version control systems allow multiple developers to edit the same file at the same time. The first developer to check in changes to the central repository is the one who gets access. The system typically allows users to merge further changes into the central repository while preserving whatever changes that the first developer made when other developers check in. Merging two files can be a slippery slope, which often requires the files in question to be simple in nature, such as text files. You may have already guessed from our previous lessons that text files are among the simplest format, and they would logically be the easiest to merge. It's a wildly different story in the files in question. If the files in question are binary files, the result of a merge of two image files might not result in an image file at all. You might have encountered this if you've tried to merge files before. The second developer checking in the code will need to take care with the merge to make sure that the changes are compatible and the merge operation does not introduce its own logic errors within the files. This is where the shortfalls of automatic and semi-automatic merge operations start to show. Unless a specific merge plugin is available for all the file types, it's not a simple walk in the park. The use of reserved edits can provide a different way of explicitly locking a file for exclusive write access, even when the system is capable of merging. The terms baseline, labels, and tags are common in most systems and refer to the process of identifying a snapshot. Label the project or a recording of the snapshot. Try it with baseline X. Typically, only one of the terms is used in documentation or discussion, although they are considered to mean pretty much the same thing. In most projects, some snapshots are more significant than others, such as those used to indicate published releases, branches, or milestones. When both the term baseline and either of the label or tag are used together in the same context, label and tag usually refer to the mechanism within the tool of identifying or making the record of the snapshot, and baseline indicates the increased significance of any given label or tag. As with any software package, the terms used in each system may be different, but most terms that describe core functionality typically remain the same. We're going to run through this list of commonly used terms and their meaning. This glossary of terms, according to Wikipedia, is a perfectly simplified version that encompasses all the most popular terms across the board. The other great thing about this list in particular is it's as simple as it gets. Let's run through the list. So, a baseline is basically an approved revision of a document or source file to which subsequent changes can be made. Atomic operations. An operation is atomic if the system is left in a consistent state, even if the operation is interrupted. The commit operation is usually the most critical in this sense. Commits tell the revision control system to make a group of changes final and available to all users. Not all revision control systems have atomic commits. Notably, CVSs lacks this feature. Branch. A set of files under version control may be branched or forked at a point of time, so that from that time forward, two copies of those files may develop at different speeds or in different ways independently of each other. Change. A change, or diff or delta, represents a specific modification to a document under version control. The granularity of the modification considers a change varies between version control systems. Change list. on many version control systems with atomic multi-change commits. A change list, or CL, change set, update, or patch, identifies the set of changes made in a single commit. This can also represent a sequential view of the source code, allowing the examination of source as of any particular change list ID. Checkout. To check out, or CO, is to create a local working copy from the repository. A user may specify a specific revision or obtain the latest. The term checkout can also be used as a noun to describe the working copy. When a file has been checked out from a shared file server, it can't be edited by other users. Think of it like a hotel. When you check out, you no longer have access to its amenities. Clone. Cloning means creating a repository containing the revisions from another repository. This is equivalent to pushing or pulling into an empty, newly initialized repository. As a noun, two repositories can be said to be clones if they are kept synchronized and contain the same revisions. Commit as a noun. A commit or revision, SVN, is a modification that is applied to the repository. Commit as a verb. To commit, check in, CI, or more rarely, install, submit, or record, is to write or merge the changes made in the working copy back to the repository. A commit contains metadata, typically the author information and a commit message that describes the change. Conflict. A conflict occurs when different parties make changes to the same document, and the system is unable to reconcile the changes. A user must resolve the conflict by combining the changes, or by selecting one change in favor of the other. Merge. A merge or integration is an operation in which two sets of changes are applied to a file or set of files. Some sample scenarios are as follows. A user working on a set of files updates or syncs their working copy with the changes made and checked into the repository by other users. A user tries to check in files that have been updated by others since the files were checked out, and the revision control software automatically merges the files, typically after prompting the user if it should proceed with the automatic merge, and in some cases, only doing so if the merge can be clearly and reasonably resolved. A branch is created. The code in the files is independently edited, and the updated branch is later incorporated into a single unified trunk. A set of files is branched. A problem that existed before the branching is fixed in one branch, and the fix is then merged into the other branch. This type of selective merge is sometimes known as a cherry pick to distinguish it from the complete merge in the previous case. Promote. Copying file content from a less controlled location into a more controlled location. For example, from a user's workspace into a repository or from a stream to its parent. Pull push. Copying revisions from one repository into another. Pull is initiated by the receiving repository, while push is initiated by the source. Fetch is sometimes used as a synonym for pull, or to mean a pull followed by an update. Pull request, a developer asking others to merge their pushed changes. Repository. The repository or repo is where files' current and historical data are stored, often on a server, sometimes also called a depot. Resolve. The act of user intervention to address a conflict between different changes to the same document. This list covers only the most commonly used terms. You'll find others in the summary notes. As is now the norm in this section of our course, the last stretch of our lesson is dedicated to our project. Today, we're going to flesh out the pseudocode and outline what exactly the functions that we chose for our program are going to do. This is going to serve as the low-level document for our code. Our demo today is primarily centered on our project. You might have started yours already since we gave the problem statement in our previous lesson. Remember, there is no universal solution. So what I am going to show you is by no means the only way you can solve the problem. As we always say, there are a million ways to kill a cat. You might see that your pseudocode is very different from what we're going to show you, but it's pretty much what will give you the same result. Remember, the focus in computer science is just to make sure that the code is doing the right thing and is doing the right thing using the best way possible in terms of efficiency and effectiveness. Enough chit-chat. Let's go. It's that time of the lesson again. We get to look at the practical side of things. And today we're going to start off by looking at a website that is a nifty tool that you can use in solving problems in your code and things that you don't quite understand. So, the site is called Stack Overflow. And this is where you can get just about anything in just about any programming language that is found on Earth. Let's say we want to find something about C programming. Just go over here and type C programming. You get quite a lot of answers concerning whatever you will have asked. So let's take, for example, something that is more specific, such as declaring arrays using malloc. Then you get all these questions and answers pertaining to what you've asked. You can also use the site to check for errors. So let's just take a random error like this one. Okay, then you get all those questions and answers that can help solve your problem. Okay, so last time we looked at our code, we looked at the basic skeleton of the program, and we created a flowchart that shows us exactly how the code would be flowing. And today, we want to build the pseudocode a little bit more so that when you move to writing code, it will be so much easier. So we already have the first part at the top, and now we want to flesh out our functions a little bit more. And you remember from last time, we already had our list of functions that we're going to need in the program. Let's start off with our name validation function. And we're going to add a bit more. So I typed out a bit of text there. And to make it easier to demarcate, I'm going to be using curly brackets as though I'm writing code. So we're going to get the message to print at the very top of the program. Then we print the message, we get the name from the keyboard, and we just check if the name is greater than 0. And if the name is greater than 0, then we return a valid name. If it is not, then we show an error, and that's that. Now, the finer technicalities are what we are going to be dealing with when we write the code. But as you can see here, we already have a roadmap to follow. Next up, we have the date validation function. And we're just going to type out a bit more text there. Now, to make it just that little bit clearer, we expanded this just a bit more. So you remember from mathematics that a leap year should be divisible by 4, by 100, and by 400. And that is the check that the program is going to make at the very top here. And if that is true, then it's going to return 1. And if it's not, then it will return a 0. Then it's going to compare the date against the maximum year that we said at the very top here and the minimum year as well. Then return 0, if that is correct. It will also check the date's months so that it is between 1 and 12. And it will check if the day is between 1 and 31. Then for February, as you all know, Feb should be handled separately. It'll check if the date is valid to check if the year is valid as well. And that whole bunch of code. So we'll do it much more clearer in the code as well. But again, we already have an idea of what we're going to be doing. Next up, we have the function that is going to deal with the student database. And here we're just going to open the file. We're going to display the header file. So we're going to display the header and get the student ID. Then college application function, which is going to check if the student doesn't already exist in the database. Then if that succeeds, then we capture the student's details, get the date validated using this function above here. Then close the file and go back to the main menu. And that's just about it. We're going to flesh it out again in the code. So we move to the duplicates function. That is the function that is going to check for the duplicates in the database, which is going to flesh it out again. So this function is going to open the file and display a header that matches the function. And we get the student ID from the keyboard. And as soon as we get the student ID, we then search for the record in the file. If it is found, then we display the record along with an error message that we cannot add the student because that particular student already exists. Then we proceed to close the file and go back to the main menu. And if the student is not found in the record, or rather is not already in the record, then we can continue with the operation and return the student function to add the student to the database and add the student. Then next up, we have a function for searching for students in the database, which we are going to flesh out like all the others. So this function is going to open the file first, then show the appropriate header, then get the student IDs from the keyboard, and if the student ID is found, then it proceeds to display the record that contains that ID. If it's not, then it closes the file. If it's not found, then it just simply shows no record and goes back to the main menu. Next up, we have the function for viewing students in the database. So this function is just going to take everything in the database and display it. Let's just type out a bit more there. So this one is one of the most simple ones. It just opens the file and shows the appropriate header. Then for each student, it's going to display the student details and the student count, which is just a way of keeping track of the position of the student in the database, then closes the file. Then if there are no records to display, it just shows no records. Then when you're done with that, you go back again to the main menu. Okay, then we have the function for deleting an entry. So what we have here is we open the file, then read the student ID from the user, then locate the record. If it is found, then we just go ahead and delete it, or else we'll just show an error message. Then close the file and we go back to the main menu. Next up, we have the function to update credentials. This is just going to show the header that shows the function that we want to perform. It opens the file, then we read the username and password. Now, remember our configuration file had a default username and password that we specified at the top. So this needs to be overwritten so that we can log in with a new username and password. Then that is saved to the file and close the file. Then instead of the person just continuing using the program, we log them out. Then we call the login function so that they can immediately test out the new username and password. Next up, we have the menu function. And this is really very simple. It shows you a header that just displays the menu, so the word menu, and chooses the menu items. And for each menu item, it's going to take you to any one of these functions. Next up, we have the login routine. This is also pretty much simple. It allows 3 tries, so it shows the header. Then if the user tries 3 times and it shows an error message, it exits. And if the user is successful, then it just goes ahead and shows the menu function. And that's just about it. And we go to the file checking function. So the purpose of this function is just to initialize the program if the file does not exist. Now, you remember we set our structures and variables right at the top there, all the way up there. So this has to be written to the file for the program to execute correctly. So that is what is going to be done in the initialization file and the initialization stage. Then we're going to set the username as Shaw and the password as Academy. And if the file doesn't exist, then it just goes ahead and creates the file. Okay, so that's pretty much all the code that we're going to be needing. So what is left here is just to head over to our IDE and start writing code. So while you cannot directly execute this file, you can use it as a reference when you're writing code. So let's say, for example, you want to flesh out this function over here. Over here. So you're now just going to go there and add your fopen whatnot. And that's already a line of code. And you might want to create additional functions for things such as this. That would display the header, since you notice that each of the functions are going to display a header, which is what I chose to do in my solution. Then you're going to flesh out all these routines. Use fclose to close the file. You're going to use your search functions to search for records and whatnot. So it's a good idea to reference previous lessons whenever you get lost as to what you're supposed to do. And again, I would like to stress this. This is not the only solution to the problem. You can create your own that does have a whole lot of other different things from what I've done here. So this is pretty much extremely simple, and you can do it in a much more complex way. So that's it for today's demo. Next time, we're going to be looking at the actual code and go into the testing of the program.